Yeah, hope everything stays that way. Okay, so welcome everyone. I'm Balázs Gerlei. I work at Unsecurities, and today I will talk about WebViews, as already said. Now, the title of the talk is Overcoming Unsecurities in WebViews. I'm fully aware that there's no such word as unsecurity, though what I will talk about today is the insecurity you may feel when working with unsecure WebViews. Uh, let's get into it after a very quick intro, because there's a bunch of things to show with a couple of demos as well. So first of all, as I said, I work at Noise Security, and I'm grateful to work there because I can work on interesting security topics like this. Basically, the company is a customer identity and access management, or CM company. It works both on-premise and cloud. We provide solutions end-to-end from the backend side all the way to the mobile side, what I'm working on. Basically, we are experts in authentication. Our solutions, for example, protect over 80% of the transactions in Switzerland. We work in Germany, Switzerland, UK, and Hungary, where I am based in. So we develop both SDKs and mobile applications. Okay, so WebViews. I'm sure that almost everyone, if not every one of you, worked or at least heard about WebViews. Had the unfortunate thing to work with WebViews. Basically, it's the default way to display web content in Android applications. It's built on the open source Chromium project, just like the Chrome browser, and originally it was part of Android itself. So it was built in, and every time Google wanted to release any kind of security updates, they basically need to issue a full Android OS update. I think you can see what's the problem with that. Luckily, that's no longer the case. Actually, since Android 5, so quite a while ago, or API 21, if you will, it's a separate application that is now distributed through the Google Play Store, just like any other application on Android. But there was a switch, basically, or a twist in the middle, because on Android 7, 8, and 9, for some reason, it's built into Chrome. It's a feature of that. But after that, from Android 10 again, it's a separate application. Okay, let's see some of the classes, just so we are on the same page what we are talking about. We will get to the meat of it, and the meat will be actual security issues and how it can be exploited and mitigations. But first, start with the relevant classes. So we have WebView, of course. That's the core class. And how it works under the hood, I won't get into the nitty-gritty details there, but it's an interesting follow-up if you want, because as I said, it's a separate application, but it kind of vends views into your application that you can use. And that view is the WebView. It has the load URL and load data methods, which you can use to load network files or web pages, basically, or data locally HTML, for example. Then we have the web settings, where you can basically toggle some of the preferences or properties, or as you will, of the WebView, like enable JavaScript if you like to live dangerously, or for example, set tags. Then we have the WebView client and the Web Chrome client. Now, why are they separated into two classes? I don't know either. I mean, some of the callbacks are in WebView client, some of the callbacks in Web Chrome client, most likely for legacy reasons. Like some of the interesting things are the should override URL loading in WebView client, which gets called before a URL is loaded, of course. Then there's on progress change in Web Chrome client. That's the place where you can be notified on the loading's progress. The WebView client doesn't have a way for that. You can get into documentation to read more. But how to actually create the web view? It's still a view, so you need to kind of use the view system. You can create it with a layout or add it to your layout resource XML, as you see in the screen. Then you can get a reference to it, like with data binding, view binding, or in the old school way, find view by ID. Then you can set the WebView client and of course the Web Chrome client as well if you need that, and then call, for example, load URL to load an example page. You can, of course, create it from the code as well. You can then add it to the view hierarchy if you want, or you can even use it in a kind of headless way, basically not adding it to the view, so it's not even visible to the user, but you can still evaluate the JavaScript that you load from somewhere and do things like that. Now, I said it's part of the view system, but you can use in a way with Compose as well, Jetpack Compose as well. There's no composable for WebView, though via Android view, basically embedding a normal view in a composable, you can still add it, and then you can instantiate the web view in the factory part of the Android view and call methods on it in the update lambda as well. Okay. Now let's get into the interesting part. This will be structured like I will show you some of the gotchas and security problems. Then I will talk about how it may be exploited and then how you can mitigate against it. Now it won't be, neither will be an exhaustive list, nor the examples can be exhaustive because there is, interesting, or if you have enough creativity, you can exploit these kind of stuff in different things, but the focus will be how to protect against them, because of course that's my aim, is to share you these. Okay, opt-out metrics collection. I think a lot of you basically remember, or if you're not, so you can set up a new Android phone, and then it asks you whether you would like to share statistics with Google. And if you say yes, or the user says yes, that would mean, and I'm not sure that you know that, that would mean that WebViews will share anonymous statistics with Google as well from inside every application that's installed on the phone. But as a developer, you can still opt out of this. You can add this metadata for the inside the application tag of your manifest file, which is basically WebView metrics opt-out with a value true. And then your applications won't send those statistics, or the device more likely, or specifically won't send that statistic to Google. Now, this can be I don't know, privacy concern of the user. And as I said, by default on Android, WebView is a separate application. And actually, I can show you that with the first demo. So, and I also said, if you remember, that on 7, 8, and 9, it's built into Chrome. And you can see what is the WebView implementation if you go to the developer settings of your phone, and then see the WebView implementation. As I said, you can see that Chrome is selected. Now, this is a selectable list, but on all of the normal non-rooted Android phones, this is not changeable by the user. It would be a problem if it would be changeable, because then another application can be selected, which basically gets into every application. Now, if I show you a newer device, you will see that it's no longer Chrome, but the WebView application, standalone WebView application. As you can see the version here, which is also interesting because as a developer, I don't know a way to get the version of the WebView on the particular device. Now, one last thing with this that I would like to show is, as I said, it's not a selectable list, but on a rooted device, which I have handy, it is. And you can, I don't know, reason that you change the WebView implementation yourself on a rooted device to change to one that doesn't send statistics back to Google. Now, I won't recommend this actually because it's still developed by some group on the internet. So I'm not sure whether it's better than sharing the statistics with Google or using other implementation. Okay, back to the slides then. This was just warm up. Remote debugging. I don't know if you encountered this when developing WebViews, but you can debug WebViews from Chrome. But be sure that you don't left it in after a development session, because then, from outside, like a reverse engineering, in a reverse engineering way, someone who wants to reverse engineer up, you can connect to the WebView that is running in your application. To do that, you basically use this Chrome inspect devices. And actually, I want to show this quickly. Okay, it's a little bit finicky, so if it doesn't work, I will go forward. Yeah, for some reason, it doesn't want to detect the device. Anyway, so when you do this, basically, you can even run JavaScript code or change the DOM of the device that is connected. Now, move into something that is more fun, breakout. I'm not talking about the retro game here, though this is, in a way, a game of itself that you can play as well at home if you want. But breakout is basically, if you don't restrict the URLs that can be loaded into a WebView, then the user can find a way to navigate away from your application to a search engine like Google, and then from there access any kind of website. Now, this is just a fun way of showing it. The real problem here is not the user navigating away, because how it would be able to, how an attacker would be able to exploit that. They basically need access to your unlocked device. How likely is that, But that also means that a JavaScript, for example, can navigate from your application to any kind of site without even, going through Google or something like that. And then that site can contain exploits. How the JavaScript gets loaded to the application in the first place? Well, again, this is a place where I will say that it depends on the creativity of the attacker. But let's imagine just one example. What if there's a help and support forum that is accessible in a web view in an application? Then that help and support forum can have user input. Basically, the users of the forum can post things in that. And what if it's not correctly escaped and the JavaScript runs in the forum? Then a user naively navigates to your help and support forum, then the JavaScript gets loaded, and then it navigates away to like a fake login page and steals credentials. Again, that's just an example. Mitigating, it's very, very hard. But before mitigating, I will show you this as well. What is my sample? Let's quickly see. It doesn't seem to load here. Okay, it's here. So this is, for example, a relatively realistic demonstration. Let's pretend that your application wants to show Google Maps, but for some reason you choose not to use the Google Maps SDK, but rather load maps.google.com in a WebView, which is here. Then the user can basically open this menu, go to Settings, Privacy Policy. Then here you can tap the Google logo, and we are at google.com. And then you can search, view websites like r/earth like this, and look into beautiful landscape, because what else would you load in a web view if you have this breakout capability? Yeah. So if I reset the demo and you actually don't allow this with this quick toggle at the top right, then even if I do the same thing, it won't navigate away, because it will not be able to open google.com, no matter how I tap the logo. Okay, now mitigations. How this was done is basically disallowing certain URLs like search engines, but that's not the good way to go. The better is allow list. Basically, only allow the things that you want to actually show. Now, as I said, this is tricky. With the realities of modern web, and from the tone of my voice, you may feel that I'm not happy with this, but that's the reality. So with the realities, with redirects and JavaScript, even in a terms and conditions where this is very usually a problem, you cannot really be sure from the development side or at the development time what kind of websites will be opened, even it's just a simple terms and conditions. So if you can, try to do an allow list. Only allow certain URLs that you want to actually show. If you cannot, I think at least block search engines and things like that. But keep in mind that that won't protect you from automatic navigation that jumps out to some site, like with the JavaScript in the help and support example I showed you. But the allow list will help you, because the allow list will only allow certain web pages. And how to actually do this? Basically, you can override the should override URL loading that I showed you before, and then not allow the page that is not on your allow list, or block the page that's not on your block list. Again, one more thing to note is that it's more dangerous when the attacker can combine this, because this in and of itself is not a vulnerability. I would like to stress that. But combined with other things like the remote debugging enabled, or clear text traffic enabled, or man in the middle possible, it becomes more dangerous. And I mentioned that it's a game that you can play yourself. If you open the top applications from the Play Store, I'm sure that in a couple of minutes, or I don't know, half an hour at the very least, you will find an application where you go to the terms and conditions or the privacy policy, and then you can break out by following some of the links. I'm usually looking for, Google Ad Manager link or something Google, because from Google, it's very easy to access their privacy policy. And as I showed you there, it's very easy to jump to the main site. But let's go ahead because there's still much to cover. And at this point, I would like to mention that I will share the slides at the end, so you don't need to remember these from the top of your head. You can look back at later, and also the recording will be available. Okay, I mentioned clear text traffic, like when combined with WebViews, it's a problem. It's a problem everywhere, I would say, really, because then in the middle is much easier than using HTTPS, because clear text traffic means HTTP communication. Nowadays it's pretty rare that you have to use it, but I would be willing to bet that at least one of you encountered the case where you need to enable clear text traffic for some reason. But even on top of that, I don't know if you know that even if there's network security config now, so it's very easy to disable or not allow clear text traffic, and it's even by default not enabled from a certain Android version, I think Android 8. WebViews don't respect that settings before Android 8. So from Android 7, there's network security config. Even before that, you can disable it from manifest, but only since Android 8 it's respected in the WebViews. Before that, like on Android 7 even, it's not respected. Even it's disabled, WebViews will be happily loading clear text traffic. So you actually need to manually prevent loading things with the HTTP protocol. This is the should override URL loading method I mentioned, the callback. I mentioned before, where you can also disallow certain or allow these certain URLs, but this is the way that you can also filter the HTTP clear text traffic. I would very highly recommend this if you want to support all the Android versions. Now, somewhat related, before that, I would like to show something. As I mentioned, this is the network security config, XML, where you can disable clear text traffic, or in this case, enable it. But you can disable it like this. In the demo, I enabled it to be able to show something. And also, as I said previously, where network security config is not available, this is where you can disable it in the manifest itself. And also the demonstration, there's this clear text traffic page on it, which loads neverssl.com, which is, by the way, a good site to test this. I think network is for some reason not available on this phone, so I will move forward. It's not really interesting anyway. It just basically loads a non-HTTP site. So yeah. Now, somewhat related, HSTS, or HTTP strict transport security. It basically helps to protect websites against man-in-the-middle attacks. So this is only relevant if you have clear text traffic enabled. If you don't, this is not relevant, because then it won't be loaded anyway. But if you have this, you can still say that certain pages are not allowed to be loaded via HTTP, only HTTPS. There's two ways, basically. There's a HTTP preload list. I will show you this as well quickly. There's a page here. Here's HTTPS preload, where you can put your domain, and they will say that whether you are eligible to HTTP preload. For example, example.com is not. If you are eligible for HTTPS preload, that means that devices should out of the box know that you cannot connect to your domain via HTTP. So no clear text traffic enabled, even if the device has the clear text traffic enabled. So that's very useful, actually. But if you are not on the preload list, still, if your server is configured correctly, and I won't get into the website, sorry, but look into it, or your backend developer should look into it more likely. If your server is configured correctly, then even if you're not on the preload list, upon the first connection, it will tell the client that please don't connect to me via HTTP, and that client should respect it. But what I'm not sure that you know is that by default, HSTS is not enabled on Android. I think it's not enabled because by default, for a while, clear text traffic is not enabled at all. So then it's not really needed. But if you have clear text traffic enabled, you can still, in the network security config I showed you before, add this property of HSTS enforced and with a value true, then it will be enabled. Okay, opaque origin. That's an interesting one again, because I don't know if you had to write something that accesses a resource from another domain. It's especially interesting if you are loading some local data to your content that you show in a WebView, and then that local data downloads something like, or plays an embedded video, or downloads fonts, uses that. Then there's this technology called CORS, or cross-origin resource sharing, which makes it possible so that that other domain or that other server can share the resources like a font or a video with your domain, but only if your domain is on the list of accepted origins. And by default, there's this load data method. I think I already showed you in the class diagram. There's this load data method of WebView that loads local content, but that doesn't allow you to set the base URL. Then same origin checks would fail. This is the thing that I mentioned, that the other server checks whether the origin is allowed. And if it fails, and you, I don't know, search on Stack Overflow, it will tell you that disable same origin checks. Of course, that will solve it, but then you are basically circumventing the security. So don't do that, please. Instead, use this load data with base URL, which is a much nicer method than the newer method, and it's with us for a long while, I think. So there's not many reasons to not use it, where you can specify the base URL. And it also has additional benefits, like the normal standard load data method doesn't accept too many kind of encodings. Originally, it only accepted, I think, if I remember correctly, present encoding, and that was fun because then there was no built-in way to present encode string in Android. Nowadays, it accepts base 64, for example, but still, load data with base URL on top of allowing you to set the base URL accepts like UTF-8 encoding, so it's very easy to use. So to sum up, don't load data, don't use that method. Instead, use the load data with base URL and specify the base URL. What base URL, you may ask? Well, if you cache a website, for example, or cache a website, then where you cached it from, that's the base URL. If it's your own data, then use your own domain. That's the basic things, but it can be trickier than that. But figure out the correct thing, basically something that you can use to share resources with. A quick demo with here. This basically a very simple demo. It just fetches from a statically loaded HTML example.com via a JavaScript fetch API. I can actually show you that, I think. So this is the thing that's loaded in the WebView, simple HTML with the script embedded, which is calling fetch on example.com. Then displays the results or the error. And if I show you quickly, see the URL, remember that, example.com. And if you check the actual code side, one of them is loads data with a base 64 encoding I mentioned without the base URL, and the other one loads it with the base URL. How it works, if I flip this switch, it will work. It will return 200. Simple demonstration, but I think the use case, I think you would get, or you can remember or come up with use cases with that. Next one, a quick one, safe browsing. Google has this service. It's basically lets client applications check URLs against Google's list of untrusted resources. And then it doesn't allow it to load it for a while, since Android 8, actually. It's by default enabled. And it's also enabled by WebView version 64. This is a good point to remember or freshen your memory that, as I said, you are not, you cannot get what WebView version is running on the device. So with Android 8, WebView 66, I think, is the default. So that's why it's enabled by default from there. But if you support all the devices, you can hope that the users will have updated WebView implementation. Mostly they have, but this is a little bit, like a guessing game. So you don't know the exact version. But you can explicitly enable it. That's the good news. So another metadata into the application tag of your manifest and say enable safe browsing with the value true, and then it will be enabled by default. Now, file access. I'm not sure if I would get feedback. I don't see a way to get feedback, unfortunately. But if I would ask you to guess whether files on the device can be accessed from a WebView. Basically, the answer is it depends. Up to 110, it is allowed by default. So the WebView, even from a JavaScript, if it's enabled, of course, from a WebView, you can access files. You can access files shipped with your application in the assets folder. You can access files on the device storage. And yeah, you can quickly say that, oh, well, Balázs, this requires read external storage permission. So it's not a problem by default. Well, yeah, but most of the applications, I would say, use this permission. Then you can say that, from Android 11, it's more complicated because we have scope storage now and the storage access framework. That's kind of true, though. On Android 11, if an application was installed before the device is updated to Android 11, the app can still opt out of scope storage. From Android 12, this is not possible. But even more than that, I'm not sure that you knew that media files can be still accessed, easily without the storage access framework. I will show you actually, but before that, I would say that the answer is very easy. Explicitly disable it. Explicitly disable file access in the WebView. You can do it via the settings, the web settings, WebView settings I showed you before, unless, actually, of course, you have to actually provide the feature. But as I said, you don't need to parse this whole diagram. But it's actually interesting is if you zoom in here for the read section, you can see that media files that's created by your own application don't need permissions at all, not even read external storage. Media files, images, videos, sound that is created by another application still only needs the read storage permission. So don't take it granted that it's protected by other things. Disable the file access. And let me show you quickly that how it looks like. Basically, if we turn off the secure settings, it loads the file. If you see here, this is actually from the assets folder. So it's shipped with the application. That's also included in file access. But if I would write a file URL here that is on the storage, which is more interesting, let's copy this one. It will still access it if it's on your device. Now, of course, it asks for permission, but it accesses it without problem. But if I turn on the secure settings and disallow it, then it won't. So please do that. Content provider access. Again, if you were in person, I would ask you whether this is possible and where it is possible on what Android versions. And you may quickly jump to a conclusion or try with the it depends, but no. It's actually still allowed by default on all shipped Android versions. I'm not sure about 15. Actually, I didn't check it, but you can if you want. It would be interesting to see. I'm not sure why it is allowed by default, but it is. So on all Android versions, WebViews can access your providers with the content URI. That can be dangerous because if you think about it, your application has the permission to access them, even if you restrict your content providers and only share it with other applications developed by you. Your application, of course, can access it, and let me quickly show you that. Without the secure settings enabled, you can access the content. If you look at the bottom, this is content URI, and without the content provider access, allow content access explicitly disabled, you don't. So please do that. Now, let's talk a little bit briefly about cookies. Everyone loves cookies, right? So not clearing cookies, for example, that's the first thing that comes into mind. I'm not sure that you knew that the cookie jar, where the cookies are stored on device, is shared within the same process. So if your application runs in a single process, all of the WebViews, not just one, all of the WebViews share the cookie jar, meaning that if you are logged in one of the WebViews, then you are logged in on the other WebViews. And then a malicious code can, for example, steal that cookie. So let's see you have a, I don't know, login page. You log in, and then you have a privacy policy page or a support forum, as I mentioned before. Then the cookies are still there. And that's, by the way, the reason why Google no longer allows login to Google via WebViews, unless you modify the user agent, of course, but that's not the way to go. And don't even forget other cookies. Just a quick shout out to that. I don't know if you heard about it. It's by Sami Kamkar, well-respected security researchers. It's a more advanced super cookie, so to say. It puts into every little places. What is the solution? Sorry. Well, you can separate your WebViews manually into different processes. You can, of course, put it in other different activities and specify a process for each activities, but it's very tricky. I'm not sure how reasonable to do that. I tried it, so it's not fun. And And also not fun that I will talk a little bit about JavaScript, and that JavaScript by default runs on the same process as your application up to a certain Android version. But there's an actual solution as well. So you can use Android X.WebKit, which is basically Android X or Jetpack version of the WebKit packages. You have WebView compat, web settings compat, everything you want, like convenience features, dark mode, overriding user agent. But what is interesting here, multi-profile. So with that, it's actually possible to separate the cookies within or between different kind of web views. You can read up on it. Again, slides will be shared. You don't need to remember the links. But what I really want to talk about is JavaScript. Now, if you look into security issues with WebViews, the first thing that comes into play is don't allow JavaScript. All of the tutorials and Stack Overflow says that don't allow JavaScript, but you have to. Again, the realities of modern web, even a support page or a privacy policy now has JavaScript, of course. But before Android 8, be aware that JavaScript rendering runs on the same process. But from Android 8, actually now it's separated, so it cannot access the memory of your application. Also, by default, load URL can load Java or evaluate JavaScript code, but don't use that. There's evaluate JavaScript now from a file there is. So always use that. It's even more convenient to use. It has a callback. It also persists to the object between navigation. But what is more interesting that it's more secure. So don't load URL and pass to JavaScript. Use the evaluate JavaScript then. Quickly show you then. If I show the load URL or have a bar by default and enable JavaScript, you can put the JavaScript in it and it will show like this alert or do more malicious thing. But if I enable the secure settings, then even if you put in JavaScript, it won't load it in the load URL. Okay, if you accept any kind of user input, sanitize it before putting it to JavaScript, because otherwise you can run into code injection. Quickly, there's a basic way via Apache Common Text Library, string escape utils that escape ECMAScript, but it's very basic. So if you need more advanced, use OWASP Enterprise Security API or something similar, or implement your own Kotlin. In Kotlin, I would say it's not that hard to escape JavaScript properly. Look into it. If you want to actually interact with your native code from the JavaScript side, things get even more hairy. This can be a talk in and of itself. I couldn't get into every details, but if you have to run JavaScript, make sure to at least use the annotation at JavaScript interface. So only allow certain methods to be callable from the JavaScript side. Otherwise, reflection can be a way to attack your application. And also, if you can restrict the JavaScript bridge usage from the code that you ship with your application. So don't allow code loaded from the server side to call into native code of your application and break havoc. A great example would be here for an attack is that if you allow like writing a file from the JavaScript side, and the JavaScript can pass in the path, then a malicious JavaScript can pass in different kind of path and use that to write certain arbitrary code. That's not fun. So try to restrict JavaScript accessibility of your native method as much as possible. Again, look into it if you need to do this, if you are unfortunate to do this, because there's much there. Now, Jetpack to the rescue. Again, there's this wonderful library called JavaScript Engine with a big caveats, but I like this actually. I would recommend using this, but it's only available since Android 8. And also it's still in beta for some reason, even though it's developed for multiple years. I'm not sure what's the hang on with Google, please make this stable. But even if it's not stable, I would try it, I think, because it's a good one, because it don't need an activity reference, so you can use it from Work Manager service, for example. Still uses WebViews, so the WebView installed on the device need to provide this functionality. It's built into the WebView, basically. But what is important here is that it provides a way to create multiple sandboxes. You can have fully as isolated JavaScript environments with low overhead. So then it's sure that they cannot access your memory, your application's memory, or each other's memory. And it cannot make network requests, which is both, a blessing and a curse, because you cannot run the code that you actually need your network access, but at the same time, it cannot reach out to the network and download problematic code as well. Look into it, JavaScript Engine. Custom tabs, another actual solution to most of the problems I mentioned. I don't know if you heard about this. Originally, it was Google Chrome's feature. Now it's built into most of the modern browsers, I would say, almost any of them. And it's basically a way to get the browser instance running in your task. you can customize the look and feel, and shares the cookie jar with the real browser. So if the user is logged in the real browser, the default browser, for example, and you're on their devices, then they will be logged in your application as well. And then you can ask, why is this better than the breakout? What's with that and the other things? It's not your problem mostly. With a small caveat that, of course, if it employs social engineering and tricks the user, that I show you a login page and this is a malicious login page, and then they can still steal the credentials, but otherwise it's separated from your application. It looks like it's in the same task that your application runs in. You can open the recents and it will show up there, but it's in reality a browser. And then all the security complications and considerations are the problem of the browser, not your application. So try to use that if possible, or you can also open an external browser that's also secure. Okay, and I also have a solution myself. Now it's a library. It's not really a marketing, I really wanted to make this to benefit of the community. So check it out. It's a GitHub link here. If you check it, actually the demo I showed you is a simple application of the library. So Secure WebView basically toggles my Secure WebView implementation, and it's a CC0 license. So that means there's no license. You can do whatever you want. So you don't need to use the actual library if you don't want to, for example, trust, in a library that's developed by or created by a single person, even if that person is me. You can copy the code, modify it however you want. Basically, what it does is enables the secure defaults that I talked about that it's not enabled on all Android versions. This one has it enabled. It blocks out of the box the popular search engines and the chatbots and things like that. You can also specify an allow list, as I mentioned, to actually just allow a certain web page or a list of web pages to be shown. And these kind of things are secure by default. But again, you can do your own, or it's even better, I would say, to use custom tabs or JavaScript engine or things like that. Only get to WebView if you really need that. But if you need that, that's also a solution. And with that, I would like to actually thank you. Thanks for your attention. I shared a couple of links at the end. Again, slides will be shared. So you can read up on more things if you want. I would like to highlight, for example, this Android Security Evolution, which is a GitHub page I maintain, but also it's open source, so you can contribute to it if you want. It's a list of certain Android features that's only available, security features that's only available from a certain Android version. It's a good way to decide what will be the minimum supported SDK. Also, I would like to mention this Hacktricks, which is an online free free book, ebook. It's not by me, of course. it's a very good, useful resource for many different pen testing things, not just WebViews, but it also have WebView stuff. And I was Balázs Gerlei. You can see the link here for the slides will be uploaded. It's not up yet, but I will upload it shortly. And you can find me on both the dead bird side, formerly called Twitter, at Balázs Gerlei, or at Balázs Gerlei at mastodon.social. And also hit me up if you want on the Slack, on the Android Worldwide Slack. So yeah, thanks. And if you have any questions, then you can ask it now.
Thank you so much, Balázs. And there are actually a couple of questions there. So again, from Geek Jimmy, how can we securely manage file access through Android WebView to mitigate potential security risks and vulnerabilities, particularly in today's multi-platform environment?
Yeah, multi-platform is interesting, and cross-platform as well. I didn't talk about that. Again, it kind of can be an own talk. Many of the frameworks use some kind of WebView in some fashion, although not always, of course. Well, don't enable file access is a great answer, but I understand that cannot be the answer every time. So there's callbacks when the files are accessed, and by URI, it's done by URI as well. I don't remember the callback from the top of my head. I think it should override URL loading, but you please look into it, and then you can inspect the URI. It's a URI as well if you access files, and then block it or allow. Again, allow is the best. Always in security kind of ways, always try to only allow things that you actually want to provide to your application. So that's my answer.
Thank you. I hope, Geeky Jimmy, you got the answer for that really extensive question.
Again, if you want, hit me up on Slack. I'm there, Android Worldwide Slack, so I can talk.
Okay, next question from Mahmoud. How can we mitigate the security risks when any app targeting Android 10 or lower with right external storage permission can access cache contents due to lack of enforced security?
I'm not entirely sure, but that's the question here. I mean, what kind of security risk, if you check what file is allowed, basically my answer from the previous is kind of, I don't know, applies here. I would say that you can still restrict what kind of files you can access. Or if you don't want to provide file access, then don't allow it with the WebView. I'm not entirely sure, Mahmoud. Sorry if I don't answer it again fully. If you have more an elaborated question or detailed question, I can answer it on Slack.
Cool. So Mahmoud, please hit up Balázs if
Also,
you
sorry,
didn't get
quick
the
one.
answer.
You can clear the cache. That's also a good idea. But cache invalidation is one of the hardest problems of computer engineering. So.
Cool. Next question from Saqib. How secure JavaScript bridge is? What security measures should I take if we are using it?
I'm thinking of doing a talk on that because it's really a talk. Sorry, but I cannot give you a quick answer. Quick guidelines, as I said in the presentation, only allow what you need to allow. So think about it, and maybe a good also point there. Do threat modeling. I really like to advocate about threat modeling. I don't know if you know that, basically you can get together with the developers, or if you have a security engineer, for example, then they can propagate that, or they can arrange that, and then you try to create a diagram of your application where you list list the different components that you have, and what are the trust bridges where the trust levels changes, like from your own application to external resource or a WebView and your own code, and have mitigations on those places. So those are the very quick guides. But other than that, a good talk idea. Thank you.
Thank you so much for the answers, Balázs, and the whole talk. It was really extensive. And unfortunately, we're out of time. So if you have more questions, then feel free to reach out to Balázs on one of his contacts.
Yeah,
Thank you very much, Balázs.
Thank you for listening. Thank you for listening. Thank you for having me. Bye.